Here's your pre-calc lecture for 10.2.3 conic sections in parametric form. In this chapter, you've studied graphs of parametrically defined functions and conic sections. But how can you apply what you know about parametric functions to conic sections? So 10-1, we're just going to do one problem with A, B, C, D. Conic sections in parametric form. Graph each set of parametric equations below, and then work with your team to algebraically rewrite each equation in rectangular graphing form. Be prepared to share your strategies with the class. So, actually, I did not graph these. I can probably graph them real quick as we go, but I'm going to rewrite these in rectangular graphing form. So what we do is something called eliminating the parameter. So what I'm going to do with this first one, it's got x of t and y of t, but I'm just going to call it plain old x and plain old y, and then I'm going to solve each one of these for t. So see how I got t equals that, or actually not solve each one of them. I solved the one that's easiest to solve for t, and then I'm going to plug t in right there to that one, like a system of equations kind of, and then now I can just like square this out. If I square this out, I'll have y plus 3, and then 2 times 2 is 4, right? So, but the 4, I can rewrite it as negative 5 over 4, and then, sorry, it wasn't y plus 3, y minus 3, plus 1. That makes it like this is a sideways opening parabola. Okay, and I'm not sure if I'll do graphs or not on this, but I can see that it's a parabola that opens to the side because the y is the square one. And then letter B, they have it in parametric form. There's like the x component and the y component. And then so what I do is I eliminate the parameter. But I can't, like, how can I get the t by itself, right? So I'm just going to do the best I can and get cosine t by itself. So I turn this into an x and subtracted 1 and divided by 9 to get cosine t by itself. And then over here I turn that just into a y, added 5 and divided by 9. So now I have this in terms of cosine t, and this one's in terms of sine t. And I remember from my magic book that there's a Pythagorean identity, and it says sine squared theta plus cosine squared theta equals 1. Now, why would I want to use that? Well, if you remember some of your conic sections, like the ellipse and the parabola, they both have a 1 on the right-hand side of the equal sign. So this is a nice, this is going to work out nicely, watch. So I'm going to cosine, if this is cosine t, then I can square cosine, cosine squared theta plus sine squared theta, that's sine squared theta equals 1. And then I can kind of fix it up, x minus 1 all squared, and then 9 squared is 81, and then see? So that turns out actually to be a circle. And then we're going to do letter C. Letter C. So this, you just turn it into an x, and then you add 4, and then divide by 3 to get cosine by itself, cosine t by itself. And this one, turn it into a y, subtract 9, and divide by negative 7 to get sine by itself. And then you're going to use your Pythagorean identity that says cosine squared theta plus sine squared theta equals 1. So when I square this, you can see that the x plus 4 squares out to that, and 9, 3 squared is 9, and squared this one, and that's an ellipse. So that would be an ellipse. The center is at negative 4, 9, and it's longer on the y-axis than on the x-axis. My dog's going crazy. One more problem. So this one starts out with x of t, and I'm going to go ahead and turn it just into an x. I'm going to subtract 5 from both sides and divide by the negative 8, and that gave me secant t by itself. And over here, turn that into a y, add 4, divide by negative 1 to get rid of that negative, and I get tangent. And then I looked in my magic book, and it also had tangent squared theta plus 1 equals secant squared theta. It's one of the Pythagorean identities. So if I want to switch that around to try to see if this thing is maybe an ellipse or a hyperbola, then I would just subtract tangent theta from both sides, and I'd have secant squared theta minus tangent squared theta equals 1. So this is the secant. If I square it, the negative 8 turns into the 64, and here's the tangent. Square that. And when I square the negative 1, it's positive 1. And that's a hyperbola. And so that's a hyperbola. The center is at 5 and negative 4, and it opens up to the sides. And I think that's all I'm going to do for this one, 10.2.3, and just check it out. And if you want to graph any of these, you can get your Desmos and graph them. That's it.